So now we look at this last one. This last one is 2 over x squared minus 1. So we'll say, okay, what about if I now have the integral of 2 over x squared minus 1 with respect to x? How am I going to think? There's no 1 here and there's no x, okay? So how am I going to work with this one? Well, the first and the other thing I want to show you is there's a subtraction sign. When there is a subtraction sign, I have x squared minus 1. I can see that this is the difference of two squares. Difference of two squares, yes. It's when you have two square numbers subtracting each other. Square numbers is the answer a square number is the answer you get when you multiply something by itself. So if I say x times x, I get x squared. That's a square number. 1 times 1, I get 1. That's a square number. So here, these are square numbers. And what I do is I get the square root of x squared, which is x, the square root of 1, which is 1. And I'm going to have two brackets, okay? When I factorize this, it'll be 2 over. When I factorize this, I'll get x plus 1 multiplying x minus 1. And I'm integrating these two with respect to x. Now, once it gets to here, then I can be able to use the idea of partial fractions. Partial fractions, yes. When you have two denominators and you want to separate them and integrate them separately, the only way to split denominators is to use the idea of partial fractions or to convert them to partial fractions. So this is the thing which we're going to do. So I would have the integral of 2 over x plus 1 multiplying x minus 1 with respect to x. And this we know would become, we deal with the denominator. So I have, this is my first denominator, here is my second. Here, this is a linear thing because the highest power of x is 1. So it's going to be a over x plus 1. Okay, then I say plus, since here it is also the highest power of x is 1, it's just a b over x minus 1. And now we have to find a and b. By doing what? First of all, have the common denominator. We are not yet doing the integral, sorry. We're first doing with this. We are not yet doing the integral. So this is going to be like this. And you can say that 2 over x plus 1 multiplying x minus 1 is going to be equal to, I need to have this as the same thing. X plus 1 multiplying x minus 1. We need a common denominator. The left and the right should have the same denominator. I would say x plus 1 into this denominator. It cancels with x plus 1. You remain with x minus 1 to multiply a. So a is multiplying x minus 1. Plus b is over x minus 1, which cancels with x minus 1. You remain with x plus 1 to multiply b. So it's b multiplying x plus 1 like this. Now, what is it going to be? Since I have two fractions now that are equal and their denominators are exactly the same, it means the numerators have to be the same. So 2 is equal to a multiplying x minus 1 plus b multiplying x plus 1. Now, here, very easy. We can let x be 1, okay? So you can say let x be equal to 1. So 2 will be equal to a multiplying 1 minus 1, okay? Plus b multiplying 1 plus 1, okay? And I would get 2 being equal to 1 minus 1 is 0. So a by 0 plus b times 1 plus 1, which is 2 now. So here I would get 2 is equal to 2b. And b goes to the other side. 2 over 2 is equal to b. And that is 1. Okay? And now, what do I have? I have what b is. I now need to find what a is. So I can say, I know what b is 1. So I can now say 2 is equal to a multiplying x minus 1 plus 1, which is b, multiplying x plus 1. Okay? Now I can let x be any number basically. So we can say let x be equal to 0. You have 2 is equal to a by 0 minus 1 plus 1 by 0 plus 1. So this is 2 equal to 0 minus 1 is negative. So it's negative a. And then plus here we have 1 times 0 plus 1 is a 1 times 1 is 1. So it's 1. So now I can say, okay, no problem. Take a to the other side. I'll have a being now positive. Then here I had a 1. 2 now comes to subtract. And I have a is equal to 1 minus 2 is a negative 1. So now I have a and b. And now I can rewrite to say that... to say 2 over x plus 1 multiplying x minus 1 is going to be, we saw that it was a over x plus 1 and a is minus 1, so it's going to be negative 1 over x plus 1 plus here b is 1, b is a 1, and it would be, sorry for that, it would be where are the partial fractions? It'll be here, x the b is over x minus 1. So b is a 1 and it's over x minus 1. So plus 1 over x minus 1. And this is what you'd have. And now you can do the integration, and you'd say the integral of 2 over x plus 1 multiplying x minus 1, or you can do it the extended version. It is the integral of 1 over negative x plus 1 plus the integral, this is with respect to x, okay? Like the negative here, you can put it outside, then you say plus the integral of 1 over x minus 1 with respect to x. So now what am I going to do? Here we have negative 1 over x plus 1. What is it now? This is like the integral of 1 over ax plus b. Okay, we talked about the integral of 1 over ax plus b with respect to x. I don't know if you remember. Now, since this is not a 1 over x, we know that it is going to be ln of that, x plus 1, right? But then we are going to divide by the derivative of the bottom, which is derivative of x plus 1 is just a 1. So nothing is going to change. Then here we say it will be plus ln of x minus 1. Okay, it'll be ln of x minus 1 here, and we divide by the derivative of that x minus 1, which is 0. So this is just what it is, and you're done. Okay, now this should help you and just show you the methods which you've been talking about. We put the constant of integration c there, and yes, that's it. So we now go to finish up our question, since we now know the cases of x squared and we see how to finish it.